Take your notes.
Yes, sir.
That is completed, na? SP and SP2, I think completed, na?
Hmm?
SP and SP2 hybridization completed, na?
Yes, sir.
Okay. So today we are going to study the SP3.
Okay,
For
sir.
SP3 also completed. Can you check please? SP3 also completed or what?
All.
SP3 completed. Okay, so SP3 means next we have go for SP3D. Okay, so I have taken some material from Narayana book. Okay, so let's try to understand this one. So here we got this is what that is. This is again SP3 only. Here we are going SP3D. Please check out. So what they are saying, if you are talking about SP3D hybridization, right? So when you talk about SP3D hybridization, so which orbitals are going to participate, that we need to understand. So if you're talking about SP3D hybridization, see, one s orbital, three p orbital, and one d orbital. So total what is there? One s means we have to write s. 3p, they are talking about 3p. So p power going to be 3 and 1d. So that is, it is going to be d. So sp3d, this is going to be hybridization. It means if someone is asking that is what is sp3d hybridization, so that is 1s orbital, 1p orbital, 3p orbital and 1d orbital. Will it be okay?
Yes, sir.
Now you see that is what is the bond angle in sp3d hybridization. So two types of bond angle are there. One is the 90-degree, another is 120-degree. Now we need to understand S character. I will tell you later on. So first of all, let's try to understand this one. So if you talk about this one sp3d hybridization, Jana, example is PCl5. PCl5.
Yes, sir.
Okay. So for PCl5, you can check out that is how many Cl atom are there. You can see 5 Cl atom are there. Yes or no? You can see here 5 Cl atom are there.
Yes,
Yes.
sir.
So
Yes, sir.
5 Cl atom, it implies that 5 bond. Okay, 5 bond. 5 bond implies that 5 unpaired electron required. It is required
Yes, sir.
5 unpaired electron. So now we have to check that is how many unpaired electrons are present in phosphorus. So phosphorus, if you are doing configuration, that is phosphorus is 15, and you can do that is here is 1s2. This is the inner shell. Then it is going to be 2s2, 2p6. This is the inner orbital. That is nothing to do with the inner orbital. Now we are going that is 3s2, and then we are having that is 3p5. Okay, so what you can do, you can add out that what are the total are coming. Okay, so total electron
Yes,
here here you can see that is 2 electron. Then here is how many are there? 8 electron are there here, 8. And here is how many are there? I think this is not 5, is not correct. Here is 3 will be there. This
yes,
is
sir.
okay. So if you are adding this one, so 2 plus 8 plus 5. So it is going to be 15, that is correct. But what is they are saying that is unpaired electron we need to check. Unpaired electron. So how we have to check unpaired electron? 3d0 is there. So here you can see that is 2 electrons are there, but these 2 electrons are paired. In the p orbital, you
Yes,
can
sir.
say, you can check that is 3 electrons are there, 3 unpaired are there. But how many required? 5 unpaired required, because 5 bond required.
Yes,
And here
sir.
d orbital are vacant, completely vacant. So what they are saying, this is the ground state configuration. This is the ground. Now what we are going to do, we are providing the P15 and we are sending this one to excited state. This is going to be excited state. Now if you are sending excited state, so one electron of it, this is going to jump here. Okay, so if one electron is going to jump here, so you need to check that is how many unpaired electrons are left. So here are 1s2. This is nothing to do inner orbital, nothing to do in the hybridization. So this is remain same. Now it will be 3s1 because one electron is going here, 3s1. Then it is going to be 3p3 and 3d1. Now you check that is how many unpaired electrons are there. Can you check how many unpaired electrons are there? So 1, 2, 3, 4, and 1 in the d orbital. Okay, 1 in the d orbital. So you can check that is total 5 unpaired electrons are there. Yes or no?
Yes, sir.
So 5 unpaired electron means this is going to be going to be which type of hybridization? sp3, because one s is there, 3p is there, and 1d,
Yes, sir.
sp3d. So total 5 orbitals are going to participate, so 5 new orbital will form. So that is one orbital will be like that, this one. Another orbital will be like this one more orbital is like that, here is like that, and here is like that. So total 5 orbital are there, and these orbital what we are going to do, rearranging, how they are going to rearrange themselves. So here you see, so one orbital will be there like that, one, right? Another orbital will be like this side, that is 2, and here will be another orbital that is going to be 3. So these the 3 orbital is the trigonal shape. Will it be trigonal shape? Yes or no?
Yes, sir.
And another orbital you will find that is here, it is going on the top, and another is the bottom. If you are joining this one, so that is one pyramid upside and another pyramid is bottom side. So what is the shape it is going to be? This is called trigonal bipyramidal shape. So shape, if you are going this one, trigonal, here is trigonal, bi, and up and down pyramidal is there, pyramidal shape, trigonal bipyramidal shape. And what will be there,
Yes,
Janab? Cl atom is there, Cl will be joined like this. Here will be the Cl, one Cl, another Cl. If you are going to be, Cl means p orbital of Cl, so that is Cl second one. Here if you are joining this one, Cl third one, this one is, if you are going, that is Cl, it is going to be Cl fourth one, and one more will be Cl. Here you can see this is Cl. So total these are the Cl are joining. Here that is sigma bond is going to be formed. This one, this is going to be the
yes,
second one. Here is, you can see this one, the third one. Okay. Here you can see this is the fourth one, and this is the fifth one. Okay. Now come to the
yes, sir.
bottom. Okay. So phosphorus is in the center. Here is one chlorine
Yes,
atom.
sir.
This is Cl atom. Here is going to be Cl atom. This is going to be Cl atom. This is going to be Cl atom. Now, so this is the, what is the trigonal shape? This is the
Yes,
trigonal
sir.
shape. Okay. Here is the pyramid shape. Now, if you are talking about the bond angle, so where is the bond angle? This bond angle is called 120 degree, equatorial bond angle, 120 degree. So they have mentioned the bond angle is 120 degree. This bond angle, another bond angle we are having, if you are going this bond angle, this one, only this one. So this is the 90 degree, axial bond angle 90 degree. Okay. So this is what all about the sp3d hybridization, how it is taking place. All the bond length are almost equal, all the 5 bond. Can you be able to understand?
Yes, sir.
Okay. So what can I do? Should I erase or you want to write anything of this?
Sir, you send screenshot.
A screenshot, but I need to take the screenshot. Okay. Otherwise, you can take the screenshot. That is also correct one. Is it possible by you to take the screenshot, or should I take? Because
No, sir, you take.
okay, then if I will take, you need to little bit wait, because at the end, what is happening, Janab? At the end, what is happening? Immediately, sometime screen get disappear, disconnected. So during that time, we suffer. That is the, so I am taking the screenshot. Wait. So I took the screenshot of this page. So we are moving to the next page, right? Can I move next page?
Yes, sir.
Okay, okay.
Yes, sir.
Hmm. So this is, I think, over. Not moving at all. Oh, the page only moving. It is not moving. Okay. See. In the PCl5 only they have given here, they have discussed this one in the PCl5. How they have discussed, you can, you can check in the notes also. Okay, so I am teaching you here, you see. Okay, here you can see formation of PCl5. The ground state and the excited state of outer electronic configuration of phosphorus they have given. So here in the ground state, what is there? 3s2 and 3p3 and 3d0. But in the excited state, one electron of this has transferred here. So see, you can see that is electron gone. So total electron 1,
Yes,
2,
sir.
3, 4, 5. 5 electron total become 5. This 5 electron undergoes hybridization. And if it is undergoing hybridization, so at the end you can see this is the 5 Cl are going to join. Okay, you can see here the 5 Cl atoms are joining here. Now these are the 5 Cl. So what is the going to be the shape? You can check. So shape, if you are wanting here, that just now we explain na, trigonal and bipyramidal shape. Will it be okay? Will it be fine to you?
Yes, sir.
Okay. So this hybridization we are lifting. Some more example, other examples are there that we need to keep in mind. What are the other hybridization of this one? SF4 is there, same one. SCl4 is there, I3 minus is there, XEF2 is there, ICl2 minus is there. This all is having the what type of hybridization? sp3d hybridization is there. If you want, I will explain any one of it. If you want, I will explain. Can I? Or can I move
Yes,
next?
sir.
Which one?
Sir, explain once.
Which one should I explain? There are so many are there. 1, 2, 3, 4, 5. 5 are there. Which one should I
Sir,
explain?
explain anyone.
Okay. Suppose I am going SF6 then now here. SF6 are there. Right. SF6. No. SF4 is there, not SF6. This is the SF4. So if you are talking about SF4, so Janab, sulfur is how much is there, Janab? That is sulfur atomic number 16. So that is if you are going configuration 1s2, then it is going to be 2s2, 2p6. They are the inner shell. Then 3s2, 3p4. Now total 4 are there. 4 bond pair. But sulfur is having total how many valence electron are there? 6. 6 are
Yes,
there.
sir.
4 to 6. So 4 bond pair are there and 1 lone pair will also be there. So because out of 6 electron, 4 shared and 1 lone pair will be there this way. So let us try to understand this one. If you are, and 3d0 configuration is there, but what they are talking about here is what is the 2 electron will be there. This one if you talk about, that is 1, 2, 3, and here is 4 are there, and but d orbital are completely filled, there is no electron. Now this is the ground state configuration, this is the ground state. Now sulfur 16 if you are going, this is supposed to be excited state, this is going to be excited state. So what is going to be there? 1s2, okay, then 2s2, 2p6, then here is what is there? 3s2, 3p, because one electron has jumped here,
Yes, sir.
3p3 and 3d1. See here. So because four bond require na, 4 bond. 4 fluorine means 4 bond, and 4 bond means 4 unpaired electron. 4 bond means 4 unpaired electron, not more than that. Unpaired electron. How
Yes, sir.
many? 4 unpaired electron required. So here is 2. This if you are going, this is 1, 2, and here if you are going, this is the d orbital are there. So you can see here the 2 electron are there, that is no problem, because we need the 4 unpaired electrons. So 1, 2, 3, and here is 4. Okay, it will be quite tough, but you need to understand this one. Now total they are going to hybridize. So how much? That is the C. One is what is there? S is there. This. How many P are there? 3, and one is there 3. So sp3d hybridization. So total how many orbital will form? 5, because it is going to sp3d. So 1s and 3p. Then what is going to be 1d. So total become 4 orbital. But these 4 orbital, how they are going to arrange? Let us see here. Let us see. This is the one here. This is going to be 2. This is going to be 3. One is going to be, this is the 4. here is going to be 5. So here is the 2 electrons are there already I mentioned. Okay, here you see, if you see this one is there, here is joined like that, this one. So you can check out, if you are checking, that is, here will be what, this position fluorine, this position fluorine, fluorine, total 4 fluorine, and one is the paired electron are there, this one. So the bond angle is
Yes, sir.
remains same. How much it will be there? 120 degree are there, and other are the 90 degree. If you are making the shape, Janab, what will be the shape here? Sulfur, here will be the lone pair electron. This is the fluorine. If you are going, this is the fluorine. Here is if you are going the fluorine, and this is going to be fluorine, right? Total, if you are talking about this shape is called, seesaw shape. Seesaw shape. This is, so this is all about our answer for this one. We can read out. Wait, I'll read out this one. What is the other points are there? PCl5 is quite easy. Then we are going SF6. Let me take the pick of this one. Oh, wait. Where it's gone. Okay, taking the pick. Yeah, take it. So now let us move out the next one. I hope little bit you may be understanding, but this explanation is not there in this book. Explanation, I will share the video. I made the video. I will share that one. So sp3d is over. Now what we have to understand, sp3d2, right? This is sp3d. Can you understand anything of this one? Whatever sp3d we study.
Yes, sir.
Okay, so we are going for the next one, sp3d2. Okay, so sp3d2, if you talk about this one, Janab, you see sp3d2, what are written here in this one? One s orbital, so that is s. 3p orbital, that is s3, and 2d orbital, that is d2. So sp3d2, this is going to be hybridization. Okay, combined to give identical orbital called sp3d2 hybridization. The bond angle are there, here is 90 degree, right? Now if you are checking this one, some other point you can check what the point they are talking about here. Example they have given. What is the example? If you see, that is SF6 is the example, you can check here. So what are the example? SF6 is the example here, SF6. So the central sulfur atom has the ground state outer electronic configuration. What they are saying? 3s2 3p4. Let me try here. Sulfur is 16. So here is 1s2, 2s2, 2p6. Then we are having 3s2, 3p going to be 6, and 3p4 and 3d, it is going to be 3d0. So if I will say what I want to say here, how many are there here? You can say also same is coming, 3s2 and 3p4 is coming. What is given? 3s2 3p4. What they are saying, in the excited state, the available 6 orbital, that is s, 1s and 3p and 2d are singly occupied. So in the excited state, what will happen, Janam? So that is, if you are sending this one in the excited state, so this all the electron means wherever the paired electrons are there, they are going to be, where they are going to be, they are going to be in the d orbital. So this one orbital here will go, and one electron is going to be here. So next configuration, what we can write? Sulfur 16. So sulfur 16, here inner cell is constant, same, no change. 1s2, 2s2, 2p6, no problem. But here it become 3s1, this become 3p3 and 3d2. Now you can check 1 unpaired. Here is how many unpaired? You can see 1, 2, 3. And here in the d orbital, how many unpaired are there? That is, here is how many? 2 unpaired. Now check out the total orbital, how many are there total. So you can see So that is one s orbital, p3 orbital, and d2 orbital, sp3 d2. Now 6 orbital will form, and how they are going to be shaped up. So 6 orbitals. So first one is square planar. Okay. So that is, this is the one. Then another is going to be, here is the going to be 2. So this is what is the 2 orbitals are there. Okay, they are the 2 orbital. Okay, this is the 2 orbital. Next one you can see, this is the going down side. Okay, this one. So they are the how many? 6 orbital, and the shape is going to be what? That is octahedral shape. This is octahedral shape. And what are their fluorine? SF6 are there now. One fluorine here, another is here, other is here, other is here, this is other, and this is other. So here that is the same they are saying. These orbital hybrid to form 6 new orbital. 6. So you can count here is 1, 2, 3, 4, 5, and 6. 6 orbital. 6 new orbital sp3d2 hybrid orbital which are projected towards the 6 corner of rectangular octahedron. So what I wrote? Octahedral, SF6. These 6 sp3d2 hybrid orbital with singly occupied orbital of fluorine atom to form SF sigma bond. Thus SF6 molecule has regular octahedral geometry as shown figure. So this is the octahedral shape. Can you be able to understand this one, SF6 molecule?
Yes, sir.
Okay.
Yes.
Little bit going faster because your syllabus is going slow na, so that going fast.
Yes, sir. No problem, sir.
So here you see, little bit try to understand here. I didn't take this one. For this one I did not take the what I was planning to take example. Wait, because I didn't take this one. Yeah. I don't know how to take this one because I didn't take this one. Wait, let me go. So, okay, let us move this one. Where is this? So this is the, if you are talking about the TCl5 already over. SF6 molecule here, here is mentioned. The shape is what they are saying, octahedral geometry. You can see this is the octahedral geometry of SF6. So sulfur 4 in the corner and 2 are in the top. So this type of shape is called octahedral shape. Okay. So this is the what the point. I hope you may be understanding. These are their Janab. Okay. What are the they have given in the list? You can see. I may go here in this page.
Yeah.
Wait. Wait a moment. Yeah. Is it visible? Screen is visible to you?
Yes, sir.
Okay. So see here little bit they have mentioned in the short form. If you can try to understand the point they are saying, that is first one hybridization, first one is there. So 1s and 1p orbital, they are saying that is if 1s is there, 1p is there. So this is called a sp hybridization. The shape is linear. And what we study example BEF2, this is the example. Okay. Some more examples are there that I will share in the form of screen. Say second one, you see 1s is there and 2p orbital is there. So this is called sp2 and trigonal planar shape. This all we study. And third one is 1s and 3p orbital. So they are talking about sp3. Okay, that is tetrahedral shape. Just now today we study this one, 1s orbital and 3p and 1d orbital. So that is sp3d trigonal bipyramidal shape. This is today we study PCl5 molecule. If you are talking about fifth one, they are saying 1s 3p and 2d orbital. If you are going sp3d2, and here is the shape is octahedral SF5. One more they have given, but that they don't ask what is their 6 number and 7 number. 1s orbital, 3p orbital, 3d orbital. So sp3d3, This is called pentagonal bipyramidal. IF7 only example is there. Another is also if you are talking about 1D, 1S, 2P. So this is DSP2 square planar, and this example is NiCN4. This will come in the coordination compound of the 12th standard. So here you need not to understand this one. Coordination compound again if you are studying in the 12th standard. So this will come. So these many hybridization type we study. I hope it may be little bit helpful to you. If you are facing any of the problem, you please inform me so that I will try to explain again. Okay. Now what they are talking about,
Okay, sir.
some problems they have given, we can discuss here. Okay, let us try to understand. Yeah. Then of the second things are which we have to understand, short form of short trick for hybridization. This is one more is there, short trick of hybridization. So what is the short trick for hybridization? This is only in the NEET exam. So hybridization, if you are calculating hybridization, so how to calculate hybridization? So hybridization is equal to 1 by 2 in bracket D plus N minus C plus A. This is the short form. So what is A for anion? This is for A for anion with sign. We have to take anion with sign. C, if you are talking about, this is the going to be cation. Cation also we have to take, that is with sign, right? Now, M for they are talking about monovalent. This is what is called monovalent. This is the monovalent. And V, if you are talking about, this is called, that is divalent. This is the divalent. Now, this is not called divalent. You can say number of valence electron. Number of valence electron. This we have to understand. Now suppose I am having the CH4. So how to calculate in the CH4? So if you are going, that is you need to see the carbon, hybridization of carbon. So that is if you are talking about hybridization, HY hybridization. So 1 by 2 in bracket what? B. B for the, that is how
If
many valence electron are there? Carbon, if you are taking carbon 6, so it is 2 comma 4. So how many valence electron? 4. So here I am writing that is 4 valence electron plus, no, 4 valence electron. How many monovalent are there? Hydrogen form always single bond because it is having one valence electron, so it is going to be always going to be formed single bond, right? So that is how many single bond it is forming. CH4 you can understand now. So how many bond it is going to form? That is 4 single bonds. So here is 4. Cation, if you are talking about cation, C for cation, there is no positive charge on this compound. So that is cation is 0 plus anion is 0. So now see 1 by 2 in bracket how many B plus M. B is 4, M is 4. So that is 8. Okay. So if you are talking about this will be cancelled out. So it is coming 4. 4 means what will come, Janab? That is 1 s orbital, 3 p orbital, sp3 hybridization. Okay, this is going to be sp3 hybridization. Can you understand this one?
yes, sir.
Okay, very good, very good. I'm okay. If I will give one example to this to you to calculate the short by short trick, one question I'm giving you. You try to calculate. Okay, can I give? Calculate hybridization in which molecule? CCl4. Can you calculate CCl4? Can you try this one?
Yes, sir.
Try. Chlorine, all the chlorine form single bond, that you keep in mind. All the chlorine will form single bond only. Are you trying or should I tell now?
Sir, 1 minute, I'm trying.
Okay, good.
मम्मा टीचर आपको फॉर्मेट नहीं बताई
Okay, Zainab, can I tell now? Hello.
Sir, I'm unable to do.
Okay, see, I'm telling you.
Yes, sir.
Wait. How can you do? Let's try it. CCl4, right?
Yes, sir.
CCl4 means if you are making the structure, how is the structure like that? Cl is here, all the Cl are there. Cl, here is Cl, this is Cl, right? Now, number
Yes, sir.
so hybridization is equal to 1/2. Here is B plus M minus C plus A. So number of valence electron in the carbon, how many are there? 4. Yes or no?
Yes, sir.
How many monovalent are there? Cl are monovalent. Cl are monovalent. No, Cl atom is monovalent. Monovalent means single bond. They are going to form single bond. They form not. How many single bond are there? 4. Yes or no? So that is here we are mentioning 4. Cation is 0 plus anion is 0. Now what we can do, that is 1/2. 4 plus 4, that is going to be 8. If you are solving 2 4 ja 8, 4 is coming. So here you see 4 means what? 1 s orbital and how many p? 3. So 1 s and 3 p, it is going to sp3 hybridization. Can't you understand now?
Yes, sir.
So this you need to try hard and you need to solve the practice exercise. Then only it will be very much helpful. Otherwise, if you are not doing solving the problem with yourself, that will be the problem, right? So I am taking the pic so that I will share you. So this is over now. Now let us move for the another topic. What is the another topic? If you are talking about molecular orbital theory. Molecular orbital theory. Okay, orbital theory. Molecular orbital theory is also known as MOT. What is molecular orbital theory, Janab? Can you tell me? Have you heard the name of molecular orbital theory?
Yes, sir.
What?
Sir, molecular orbital theory means, sir, in a orbit, the number of molecules means like in a orbit, the number of molecules present.
Yeah, you are trying. Okay, very good. See,
Sir,
Janab.
it's something about the orbits of a molecule.
Yeah, good.
Means like sharing of a molecule means like atoms
Yeah.
in molecules of the orbits.
Okay.
I
Molecular.
know, but I'm unable to say.
No, I also understand because you are the student, you are not a teacher. So 100% correct you cannot tell, but you are trying. That is the great things. You are trying almost correctly. So here you see molecular orbital theory. You know, atomic orbital are there. Atomic orbital are there. Atomic orbital. Atomic orbital related to atom, right? Related to atom. Atom is having atomic orbital. And if you are talking about molecule, right? So molecules are having what type of orbital? Molecular orbital. Yes or no? Molecular orbital. Molecules means molecular orbital. Atoms means atomic orbital. So in the molecular orbital theory, according to this theory, electrons in a molecule, what the point you was telling, that is electron in a molecule present in where you can say molecular orbital, present in molecular orbital. That is what the point, present in molecular orbital. Electron in a molecule present in molecular orbital. If you are talking about atomic orbital, electron present in where is electron present in atomic orbital. So this we study already, है ना? Covalent bond, ionic bond, this all we study. So this is not related
Yes,
to us.
sir.
Okay. Atoms combined, what they are saying is, Janab, if atom plus atom, two atom combine, what they are going to give? They are going to give, that is molecule. So that is atomic orbital AO plus AO combined to what they will give? They are going to give molecular orbital. Atomic orbital combined to give molecular orbital. Can you be able to understand this? Like atom, suppose H
Yes, sir.
plus H, they are combined to give, that is H2 molecule. So they are talking about if atom and atom combined, so it is going to give molecule. Like what? A2
Yes, sir.
molecule. Similarly, atomic orbital plus atomic orbital, they are combining AO plus AO. They are going to give molecular orbital, right?
Molecular orbital.
Okay.
Yes, sir.
So now let us see the molecular orbital theory. Oh, what I did here. Okay, I will take the peek later on. So here, if you are talking about MOT theory, so how can you understand here? MOT theory means, that is first point, electron in molecules present in molecular orbital, this is the point, electron in molecule present in molecular orbital. This is the first point. Now go for the second point. So what is the second point? Electron, okay, in molecular orbital, electron in molecular orbital, are, they are saying, influenced by two or more nuclei, okay, two or more nuclei, NuClei. Now third one, okay, number of
Yes, sir.
molecular orbital, they are talking about number of molecular orbital is equal to how much? Is equal to number of what? Number of molecular orbital is equal to number of atomic orbital combined.
Yes, sir.
This is what the point. Now
Yes.
fourth point, the molecular orbital, here I am writing the molecular orbital having more energy, energy is known as, what they are saying, is known as,
Is
what
not
they are is known as antibonding molecular orbital. This is what you are talking about, This is anti-bonding molecular orbital.
Molecular orbital.
Yeah. Have you heard
Yes,
the
sir.
name of this one, anti-bonding molecular orbital?
Yes, sir.
Anti-bonding molecular orbital. This is the point. Anti-bonding molecular orbital. Right. So these are the point, anti-bonding molecular orbital. Now, if you are going the next point,
Okay, sir.
fifth point, the molecular orbital, the molecular orbital, the molecular orbital having more energy, the molecular orbital having more energy is known as what? The molecular orbital having more energy is known as what? The molecular orbital having not more energy already you got to know anti-bonding. You can go for the less energy is known as bonding molecular orbital. Okay, bonding molecular orbital. These are the point, bonding molecular orbital. These are the point. Okay. Now, if we talk about the 6th point, anti-bonding molecular orbital (ABMO), represented by sigma star. 7-1. If you are going 7 point, so that is bonding molecular orbital (BMO). It is determined by sigma. Okay. So star means more energy, more energy, more energy, and less stability, less stability. And second one, if you are talking about here is less energy. They are talking about less energy, more energy, more stability, more stability. So these are the point. Last point, if you're talking about last point, that is bond order. Bond order. So how to bond order calculate? 1/2. So electron in BMO, bonding molecular orbital, minus electron in anti-bonding molecular orbital, ABMO. This is the formula. So these many points are the molecular orbital theory. Okay. Now what we need to do? We need to do the sum
Yes,
of the
sir.
problem. Some of the problem we need to do here. So can I change the page? Let me take the screenshot. Then only we can. I'm taking the pic. Then I will move to the next page. That is, I think this page. What is there? Yeah. Yeah, take it.
Yes, sir.
Wait. I'm taking the pic so that I will share you.
Okay, sir.
Mama Dio. Umarga. 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 Umarga क्या? वही फॉर्म फिल क्या? क्या है उमरगा खड़ा?
So these are the point which are supposed to be study, and then we are going to study the examples of this theory. No, going to solve the sum of the problem. Let me
Yes,
take the
sir.
pic last page. I'm taking. Yeah, taken. Now let's move. See, MO diagram. What is diagram? That is molecular orbital. They are talking about molecular orbital energy level diagram. Energy level diagram of molecular orbital energy level diagram of H2 molecule. This is going to be H2 molecule. So how can you study if you are having the H2 molecule? So how we can study the molecular orbital energy level diagram, right? So here if you talk about this one, H2 molecule, you see that is this is made up of 2 hydrogen atom. So we can make this one structure like this one, a straight line, 2 straight line we are drawing. So that is one straight line and another straight line. So this is the hydrogen atom. This line is explaining hydrogen atom, atomic orbital, AO, atomic orbital. This is hydrogen atom, atomic orbital AO. In the bracket, in the middle, H2 molecular orbital, right? Now, if I will ask you, what is the atomic number of hydrogen is 1, configuration is 1s1. Another hydrogen is there 1, that is 1s1. If you are talking about H2 molecule, total electron is 1 plus 1. So this is going to be 2 electron. So here you see this is the 1 electron. Here you can see this is the another electron. So here is this is going to be 1s1. This is again going to be 1s1. So here is the 1 electron. Here is again going to be 1 electron. This is okay. Now what we need to do, these are going to combine. So if you are going to combine, they are going to form that is molecular orbital. Now that is 2 atomic orbital combined, so 2 molecular orbital form. So this is what is this is the energy order, energy increasing like that. So this is the what that is going to be the how many electron 1 2. So both the electron filled here. So that is sigma 1s2, and here is no electron, so sigma star 1s going to be 0. So in anti-bonding orbital, there is no electron, here is 2 electron. So if you are talking about the magnetic properties, if you are going for the magnetic property, so magnetic property
Yes,
means PROPERTY. So magnetic property means if there is unpaired electron, okay, if there is unpaired electron, so that is the unpaired electron means paramagnet. But here is there is no unpaired electron in molecular orbital, so this is diamagnetic, that is called diamagnetic. Diamagnetic, why they are calling? Because as no unpaired electron,
yes, sir.
as it has no unpaired electron, since there is no unpaired electron, so it is diamagnetic. Now bond order, how many bond will be there between H2 molecule? So here they are saying 1 by 2 BMO electron minus what they are saying ABMO electron. Now see 1 by 2, what is BMO electron? This is the bonding molecular orbital. BMO, bonding molecular orbital. What is this one? ABMO, anti-bonding molecular ABMO, anti-bonding molecular orbital. So that is what is 2 minus 0. So what will be there? 1 by 2 into 2. So 2 cancel out. So it is going to be 1. So that is you can write that is H single bond. It is going to be H. So this is what the concept behind the molecular orbital. Can you understand little bit? Hello, Janab,
Hello,
audible?
yes, sir.
Can you understand this one, molecular
Yes,
orbital?
yes, yes.
Although it is very tough, but you need to understand this chapter is okay, not that much tough, but we need to little bit you need to self study. Okay, and wherever you are facing the problem, you may ask. Okay, daytime also you can put the message. I will solve the problem and I will share you now. But you are not asking the problem. What can I do? Yeah, you are facing the
No,
problem.
sir, I'm clear.
Okay, very good, very good. So,
Or
I'm
else I will ask you, sir, if I have doubt.
okay,
But
okay,
I do
okay,
not have doubt right now.
okay,
I
great,
understand
great.
what you're teaching.
Okay, good, good. Thank you very much. So this is the H2 molecule. Then now what I can do, can I teach the in the next class because it is getting too much matter. So it may be creating confusion. What can I do? Can I give one more problem or next class?
I'll give one more problem.
Okay, one more problem. So we are going for the He2 molecule. See, He2 molecule. He2 molecule. If you are going He2 molecule, Janab, so what is there? Helium, if you are talking about helium, helium is 2. So this is going to be 1s2. Another helium is there. So this is 2. So this is going to be 1s2, right? If you are talking about helium 2, so that is 2 electron plus 2 electron, that is going to be 4 electron. So here you see this is the helium. Today I'm giving very simple problem. In the next class we'll go for the nitrogen, oxygen, fluorine, neon. So larger problem we'll do in the next class. So here is what we are talking about. This line is representing helium atomic orbital, and this line also representing helium atomic orbital, and in the center it will go give He2 molecular orbital, He2 molecular orbital. So here you see this will be in the here, this is the what 1s2, and if you talk about this one, so this is what is going to be again 1s2. Now in the in C, in between what is there here, this, okay. So this is what 1s2 1s2. So total electron here is the, this is the energy order. So energy order. So configuration, if you are talking about molecular orbital configuration, MOC, molecular orbital. So 4 electron is there. So sigma 1s2, then it will come sigma star 1s2. So total 4 electron will be there, no problem. So here will be that is sigma 1s2, and here will be that is sigma star 1s2. So electronic field in the atomic orbital 1 2, this side atomic orbital 1 2. So total electron is 4 1 2 3 4. Now let us go for the bond order. Bond order means what? 1 by 2 in bracket B plus M minus C plus A. Now check 1 by 2. No, oh, no. Bond order is equal to this formula, not correct. Bond order is equal to 1 by 2 in bracket. What we are going to write 1 by 2 plus BMO electron minus ABMO electron. So bonding molecular orbital, this is the downside BMO because less energy, and this is the ABMO, more energy. So you can see 1 by 2 in bracket BMO electron, how many are there? 2. ABMO electron 2. So 1 by 2 multiplied by 2 minus 2 0. So that is, it is going
Yes,
to
sir.
be 0. Okay. So 0 bond order means
Yes.
no bond. 0 bond order means no bond. No bond. And
No
no bond means He2 do not exist. He2 do not exist because there is no bond, do not exist. So you know noble gases do not exist. Noble gas do not, helium is noble gas, it do not exist. So this is He2 do not exist. If you are talking about magnetic properties, magnetic. So magnetic property, you see there is no unpaired electron. Here is pair 2, here pair 2. So magnetic properties means going to be diamagnetic because MAGNE, diamagnetic, as no unpaired electron, no unpaired electron. There is no unpaired electron, so it is going to be diamagnetic. Can you be able to understand this? Yes or no?
Yes, sir.
Okay, okay. So let me take the picture. So Zainab, I am sharing you the image to you. Just you go through the this what we studied today, and remaining portion we will be able to study in the next class, right? So in the next class, we'll do the diagram of what? Be2, beryllium 2, boron 2, boron carbon 2, nitrogen 2, oxygen 2, fluorine 2. This many molecule we will study, that is molecular orbital diagram, molecular orbital energy level diagram of the this molecule A1, 2, 3, 4, 5, 6 molecule. We will go in the next class. So can we off today?
Yes, sir.
Okay. So okay, bye. Take care and
Okay.
okay. Bye.
Thank you, sir.
Welcome.